So here, this is the question number 3. AM is the median of the triangle ABC. So you have to check whether AB plus BC plus CA is greater to twice of AM or not. So here in this question, first we will see what we have. So here we'll just write the given. Okay, so given that AM is median. So if AM is the median, that means BM is equals to MC. So this is given. Now here we have to check if AB plus BC plus CA is greater to twice of AM. So this we have to check here in this question. So now to do this question, first just look at the diagram. So here in the diagram you can see this triangle is divided in two different triangles. So this is the first one, and the unshaded one, like this one, is the second one. Okay, so if we'll take in the above triangle, then we can apply the property. I'm just writing the triangle. So just mention the triangle in which you are taking. So first I'm taking the triangle ABM. So this is the triangle ABM. Now in this ABM, you can see, just see the result here. We need 2M. Okay, 2AM. So here AM I'm just keeping on the right side. So as we know that sum of the two sides is always greater than the third side, so I'm taking ABM. So your side AB and the other side is BM. So AB plus BM will be greater to AM. Okay, as we know. That sum of the two sides is always greater than the third side. So I'm just making it equation number 1. Now I'll take in another triangle, that is AMC. So in AMC also we can write the same thing, like your AC plus MC will be greater to AM. This I'm making as equation number 2. So now on adding 1 and 2, if you add the two equations, whenever you have a sign other than the equal sign, so that time you can see here you have greater sign, here also you have greater sign. So while you will add, so all the left side will be added, all the right side will be added. Okay, but the sign will come as it is. Here also you have a greater sign, here also in the second equation you have the greater sign. So the sign will remain same, only the terms which are in the left will be added. So here in the left, in the first equation we have AM plus BN, and in the left of second equation we have AC plus MC. Now I'm keeping the greater sign as it is, and then I can write the terms in the right side, that are AM and AM. So here we'll get twice of AM, and then we can write AB plus AC. I'm writing as it is. Now you can see BM plus MC. So you will see in the figure, BM plus MC is how much? So this is your BM. BM plus MC will give you BC. So in the place of BM plus MC, we can write BC. So we will get BC. AB plus AC plus BC is greater to 2AM. So that was to be checked, like whether AB plus AC plus BC is greater to 2AM or not. So we can say yes, AB plus BC plus CA is greater to twice of AM. This is the next question. Here ABCD is a quadrilateral, and you have to check whether AB plus BC plus CD plus DA means the sum of all the sides is greater to AC plus BD, that are the diagonals. Okay, so this you have to do here. So for doing this, we will use the same property of triangle, that sum of the two sides is always greater than the third side. So for doing this, first you can take different triangles. like in the beginning I'm just taking this triangle. So here you can see in these questions you just have to see in the left side what we are getting, the sides like AB plus BC, CD plus DA we have in the left side. So here we can say that your DA plus DC will be greater to which side? Greater to AC. Okay, so that will give us equation number 1. The same way we can also say, we can take the another triangle. So in this triangle if you'll take, so you can say that DA plus AB will be greater to DB. Okay, so same way you can continue. So this way you can take the 4 triangles and then we will write the equations. So first I'm taking in triangle DAC. Okay, so the previous one. So in DAC you can write DC plus AD will be greater to AC. So just make it equation number 1. Now I'm taking another triangle. Now in triangle ABC, again you can say the same thing, like the sum of AB and BC will be greater to AC. Just we are making it equation number 3. Now as you can see on the right side, we need the AC as well as BD also. Okay, so now I'm taking the triangle which is containing BD. Okay, so first I will take this triangle. So this contains the diagonal BD as well as the unshaded one. Okay, so one I'll take these triangles. So first I'm taking in triangle BDC. So here you can write that DC plus CB will be greater to BD or DB. So this will be our equation number 3. Now we can take in triangle the unshaded one, that is in triangle BDA. So here again we'll get DA plus AB is greater to side BD. This is our equation number 4. Now here again we will add the 4 equations. So on adding equation number 1, 2, 3 and 4, that we will write here. So here again we will do the same thing as we have done in the previous sum. So on adding 1, 2, 3 and 4. So here I've told already, just you have to take care of the greater sign. So in all the equations you have a greater sign like this. So all the left part will come as it is, and the right part you have to add all the right parts in each equation. So in the left side I'll get DC plus AD plus AB plus BC plus DC plus CB. All the left part I've added here, and then the right part I'll get AC plus BD plus BD. So now we can add all this. So here you can say we have BC 2 times, DC is and DC again 2 times, and AB again 2 times. This will be AB. So here you will get twice of AB plus BC plus CD plus DA. So this thing you can write like, first you can write 2AB, 2BC, 2CD plus 2DA. Okay, and then you can write, take the common. So here you will get 2AC plus 2BD. Okay, so here you can see 2 can be taken out common. So here you will get AC plus BD. So in the left part also I have written the same way as I told, and then you can take 2 common from the left side as well. So you'll get twice of AB plus BC plus CD plus DA. So here you can cancel out the 2. So you will get the required result, that is, so here you can say AB plus BC plus CD plus DA is greater to AC plus BD. So hence you have proved this one. So this is the question number 5. ABCD is quadrilateral, and you have to check whether AB plus BC plus CD plus DA is less than twice of AC plus BD. Now this question is a little bit different than the previous one. In the previous one, the same left side was same, but on the right side you needed to prove that it is greater to AC plus BD. Now you have to check whether it is less than twice of AC plus BD. Okay, so in this question we will choose different triangles. So here I am taking this triangle. Okay, now let's see what you have to prove. So you have to prove that the sum of the sides is less than the diagonals. Okay, so here what I will do, DC means all the sides we have to take, and it should be less than the diagonals. So this and this. Okay, now if we'll see in this triangle, you can see this DO is the part of the diagonal, and here again OC is the part of the diagonal. So here I will take the relation, the same thing I will take, that sum of the two sides is always greater than the third side. So I can write it in this form also, that DC will be less than DO plus OC. So this will be our equation number 1. And always remember to write the triangle in which you are taking. So here we are taking in triangle DOC, so that we will write here. So in triangle DOC, DC will be less than DO plus OC. Okay, the same way now you can take in triangle ADO. Okay, so ADO means this triangle we will take. So here again we can say that our side DA will be less than DO plus OA. So this will give us equation number 2. Now we'll go in triangle OAB or AOB. So here I can write that AB will be less than OB plus OA. So that is equation number 3. Now we can move in triangle CBO. So here you can write that CB is less than OB plus OC. So that will give you equation number 4. Now we will do the same thing as we have done in the previous on adding 1, 2, 3 and 4. So here again we will add all the 4 equations, and the rule will be same. At first you have to check the inequality sign. So here you can see in all the equations it is less than. Here also we have less than, here again less than, here again less than. So all the left part will be added and all the right part will be added. So in the left we have DC plus DA plus AB plus CB, and that will be less than. So in the first we have DO plus OC, second we have DO plus OA, third we have OB plus OA, and in the fourth we have OB plus OC. Okay, so now we can add if something is same or common. So here you can see in the left side we don't have anything common or to be added, so we can write the left part as it is, and the right side just see you have DA, DO, DO, 2 DO you have, so twice of DO I'm writing here, and then we have OC, OC, twice of OC, then I have twice of OB as well and twice of OA as well. So this I have. So now from the right part I'm taking 2 common, so then I can write DO plus OA plus OC plus OB. Okay, now we'll just see this in our diagram. So here is our triangle. So here you can see in the triangle DO plus OB. DO plus OB will give you DB. Okay, and OA plus OC will give you AC. So that only we will write here. So here first you can pair up it in this way, DO plus OB I'll pair up, and then OA plus OB I'll pair up. So here you know that DO plus OB will give you DB and OA plus OC will give you AC. So this we will write at DB plus AC. So here I can close the bracket. So the left was DC plus DA plus AB plus CB. So that is less than twice of DB plus AC. DB and BD are same, so you can write it as DB as well. This we have, this you will do in this way. So this is question number 6. The length of two sides of a triangle are 12 and 15 centimeter. So let me draw this triangle. So here it is saying that the two sides are 12 and 15 centimeter. So between what two measure should the length of the third side fall? Means this third side, what will be the range of the third side, like that you have to find out. Okay, so here we will use the property that sum of the two sides is always greater than the third side. Okay, so we can write here 12 plus 15 is 27, will be greater to x. Okay, so this I have taken by the first property that sum of the two sides will be greater than the third side. If we will choose some other sides, like I am taking 12 with x, so this I am taking as equation number 1. Now sum of these two sides can also be greater than the third side, that is 15. Okay, so here x will be greater to 15 minus 12, so x will be 3. Okay, so here you can see from the equation number 1 and 2, what can you say, that here in the first equation the x is less than 27. Okay, but x is greater than 3. Okay, so here you can limit the values of x will be between, x will be greater than 3 and less than 27. Okay, so you can say x will be between 3 and 27. So between 3 and 27 it can have any value.